Welcome, and let's prevent a solution given this nice algebra problem, which is x times x times x times x, okay, divided by x plus x plus x plus x, okay. So what are the values of x? Now, in the numerator here, this is x to power 1 multiplied by x to power 1, x to power 1, and x to power 1. So basically, here we have x to power 4 in the numerator divided by x plus x plus x plus. This is actually equal to 4x. This is equal to 16. The next step here, we find that x to power 4 divided by 4x. This is in the form of 8 to power n divided by 8 to power m, which we can express as 8 to power n subtract m. Applying this identity, we'll have x to power 4, okay, subtract, this is to power 1, subtract 1, okay, divided by 4, this is equal to 16. So let's multiply both signs by 4. Let's multiply both signs by 4. So that now here we have x to power 4 minus 1, this is 3. This is equal to 16 times 4, which is basically equal to 64. So let's take 64 on the left hand side. Here we'll have x to power 3, subtract 64, this is equal to 0. Now we can express 64 as 4 to power 3. So let's substitute this. We'll have x to power 3, subtract 4 to power 3, this is equal to 0. Now x cubed minus 4 cubed, this is the difference of 2 cubed, 2 cubes expressed as a cubed minus b cubed, which we can express as a minus b, a squared, okay, plus ab plus b squared. So let's apply this property so that now here we'll have x subtract 4 x squared, okay, plus 4x plus 4 squared, this is equal to 0. So here we'll have two parts. The first part is actually x minus 4, okay, and this is equal to 0. We have x minus 4, this is equal to 0. And we have the second part here, which is x to power 2 plus 4x plus 4 squared, which is 16. This is equal to 0. So that means that we have x1, which is a real solution here, being equal to 4. So this is the first value of x. This is the value of x, which is a real solution here. And the second part here, let's solve for the other values of x. This is a quadratic equation of the form ax squared plus bx plus c, this is equal to 0. Given that the value of a in this quadratic equation is equal to 1, the value of b is actually equal to 4, and the value of c is given as 16. So the next step, let's check the nature of the root of this quadratic equation by following these steps. Now here we have that the value of x1 is equal to 4, and the second part here we have a quadratic equation which is of the form ax squared plus bx plus c, this is equal to 0. Now we have the value of a equal to 1, the value of b equal to 4, and the value of c equal to 16. So now let's assess the nature of the root of this quadratic equation by determining the discriminant value, which is b squared minus 4ac. So let's substitute the values of a, b, and c. So here we'll have 4 squared subtract 4 times a, which is 1, times c, which is 16. So here we have 4 squared, this is 16, subtract 16 times 4, this is basically equal to 64. So 16 minus 64, this is negative 48, which is less than 0. And that implies that we have two complex roots here. We have two complex roots. Okay? So now to solve for these two complex roots, let's apply a quadratic formula, that is x2 and x3. This is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. So substituting these values, we'll have negative 4 plus or minus the square root of b squared, that is actually 4 squared minus 4 times a, which is 1, times c, which is 16. All this divided by 2. So next here, we'll have negative 4 plus or minus the square root of 4 squared, which is 16, minus 16 times 4, this is 64. All this divided by 2. The next step here, we'll have minus 4 plus or minus the square root of 16 minus 64, this is negative 48. All this divided by 2. And then we have here, this is negative 4 plus or minus, we can express negative 48 as 16 times 3 times negative 1. All this divided by 2 times 1. So in this case here, we'll have negative 4 plus or minus the square root of 16, which is actually equal to 4, the square root of negative 1, which is I, then square root of 3, all this divided by 2. The next step here, we have that 2 is common here. We can factor out 2. So that now here we'll have negative 2 plus or minus 2i square root of 3. All this divided by 2. So let's simplify here by 2 here. 2 and 2 simplifies. So that now we will have negative 2 plus or minus 2i square root of 3. So that implies that we have two complex solutions here. We have two complex solutions here. That is, x2 is given as negative 2 plus 2i square root of 3. And we have x3, which is actually given as negative 2 subtract 2i square root of 3. Now these are the two complex roots we have. And only we have one real solution, which is x1, which is actually equal to 4. Okay, so this is the real solution we have. Now let's test, or let's verify, let's check if this real solution, which is x1 equal to 4, satisfies the equation. Now let's check x1, which is equal to 4, if it satisfies the equation. Now if you recall, we ironed that x times x times x times x divided by x plus x plus x plus x, this should give us a value of 16. So here we have 4 times 4 times 4 times 4 divided by, we have here 4 plus 4 plus 4 plus 4, this should give us a value of 16. Now 4 times 4 here, this is 16, times 4 times 4, which is also 16, divided by 4 plus 4, which is actually equal to 8, and 8 plus 4, 12, plus 4, 16. This is equal to 16. So you can simplify here, and that shows that 16 on the left-hand side is equal to 16 on the right-hand side. Okay? And that affirms that we have 3 solutions to this math problem. That is 2 complex solutions and only one real solution, which is x1 equal to 4. So thank you for watching. Follow the steps, like this video, and subscribe.